সবাইকে স্বাগতম। আমরা গত ক্লাসে বাফার সলিউশন এবং এর মেকানিজম অর্থাৎ কিভাবে বাফার সলিউশন কাজ করে তার বিস্তারিত আলোচনা করেছিলাম এবং আমরা বলেছিলাম পরবর্তী যেদিন আমরা হাজির হব আমরা বাফার সলিউশন এর ম্যাথমেটিক্যাল প্রবলেম অর্থাৎ গাণিতিক প্রবলেম নিয়ে আলোচনা করব। তার আগে একটা বিষয় একটু আমরা ক্লিয়ার করে নেই, সেটা হচ্ছে আমি কন্টেন্টগুলো ইংরেজিতে করছি। এর মূল কারণ হচ্ছে ইংলিশ ভার্সনের জন্য রিসোর্সেসগুলো খুব অ্যাভেলেবল নয়। অনেকেই বাংলা ভার্সনের জন্য অনেক কন্টেন্ট তৈরি করছেন, বাট ইংলিশ ভার্সনের জন্য তেমন কোনো কন্টেন্ট খুব কম পাওয়া যায়। দ্বিতীয়ত, আমি কাজগুলো পোস্টার পেপারে করছি, বোর্ড ওয়ার্ক করছি না। এর কারণ হচ্ছে যাতে তোমরা সহজে তোমাদের নিজের নোট তৈরি করে নিতে পারো, এর উদ্দেশ্যে আমরা এভাবেই প্ল্যান করেছি বা সাজিয়েছি। এখন বাফার সলিউশনের ম্যাথ করতে গেলে বা এর পিএইচ এর ম্যাথ করতে গেলে আমাদের একটি সুইটেবল ইকুয়েশন বা সমীকরণ লাগবে, যে সমীকরণটাকে বলি আমরা হেন্ডারসন ইকুয়েশন। এই হেন্ডারসন ইকুয়েশনটি কিভাবে আসলো তা এখন আমরা দেখব। প্রথমেই আমরা দেখি হেন্ডারসন ইকুয়েশনটি কিভাবে আসলো। আমরা যদি বোর্ডে তাকাই তাহলে দেখব CH3COOH ethanoic acid, which is a weak acid, dissociate partially. It partially dissociate and produce H plus ion. As we have discussed previous class that to form a buffer solution, a weak acid is required. So if we apply mass action law for this equation, then we get equilibrium constant equals to concentration of product divided by concentration of reactant. Here for acid, equilibrium constant K is also known as Ka, which is called dissociation constant of acid, যাকে আমরা বাংলায় বলি অ্যাসিডের বিয়োজন ধ্রুবক। এখন যেহেতু আমাদের এই সমীকরণে pH আনতে হবে, এন্ড আমরা এসএসসি তে পড়েছি H plus আয়নের ঋণাত্মক H plus আয়নের ঘনমাত্রার ঋণাত্মক লগারিদমকে আমরা pH বলি। That is, pH is called the concentration of negative logarithm of H plus ion. So we need to introduce log in both sides. So we have to take minus log in both sides, and minus log of H plus turn into pH according to definition. And we know log A into B, that is log A plus log B. So by using that equation, log minus log Ka minus log acid by salt. Now we need to focus one thing. Third bracket of CH3COOH means concentration of acid. Third bracket of CH3COOH is COO minus means concentration of salt. If we can replace H from an acid, then it eventually turn into salt. So CH3COO minus can also be treated as salt. So the equation turns pH equals to minus log Ka minus log of acid by salt. So if we multiply with minus negative 1, that is minus 1, then this equation turns pH equals to minus log Ka plus log of salt by acid, that is it inversed. Here minus log Ka can also be denoted by pKa, and the equation turns pH equals to pK plus log of salt by acid. So this highlighted two equations, by these two highlighted equations we can calculate the pH of the buffer solution, and Ka is known as dissociation constant of acid, third bracket of salt is known as concentration of salt, and third bracket of acid means concentration of acid. Now let's see a mathematical problem from here. That is, if 8.5 gram of CH3OOH mixed with 18 gram of sodium ethanoate in a 350 ml solution, that is ethanoic acid and sodium ethanoate combinedly, the volume of that solution is 350 ml. Now we need to calculate the pH of that solution, and K is provided. So before that we need to calculate the concentration of acid and salt. Okay, we need to calculate the concentration of acid and salt. Here is a little correction. It will be H, that is acid. Now, so from the formula of the molarity, that is concentration of acid, S equals to 1000 W by mv. So S equals to 1000 into 8.5, that is the mass of ethanoic acid is 8.5, molecular mass of ethanoic acid is 60, so the concentration is 0.405 molar. Similarly, by using the same equation, we can calculate the concentration of salt, that is S equals to 1000 W by mv, and the concentration of salt we get 0.63 molar. Now, put these values into Henderson equation, that is pH equals to minus log K plus log of salt by acid. So Ka is given, and put all these values on the equation, and finally we get the pH of the buffer solution, that is pH equals to 4.94. If we see another mathematical problem, let's say a mathematical problem where how we can prepare, that is you can or we can prepare a buffer solution which pH will be 4.4. That is, we need to prepare a buffer solution which pH will be 4.4 and pKa is provided. Ignore the little overriding at here, and the pKa of formic acid, that is HCOOH, that is 3.74. Now, given that pKa is given, and we know from the Henderson equation pH equals to pKa plus log of salt by acid. Here one thing we need to focus at here, that is both concentration of salt and acid is not provided. That is, two of the variables are inactive. In that case, we need to find the ratio of this, and we can easily calculate the pH. So now, by the simple calculation, we can get log of salt by acid equals to 0.66, and by inverse log, that is anti-log, we can get salt by acid equals to 4.57. That is salt ratio acid, concentration of salt ratio, and if the both ratio of their concentration turns 4.57 is to 1. It means if we mix salt and acid with the ratio of concentration of 4.57 and 1 respectively, it means if we make 4.5 times the concentration of salt compared to acid, then we can prepare a buffer solution with the pH of 4.4. Now, let us see a different type of method here. The problem is, if 25 ml of 0.25 molar ethanoic acid mixed with 15 ml of 0.25 KOH, what will be pH of the solution? One thing we need to focus at here, that is, here acid and base is provided, but from the concept of buffer solution, we learn that to prepare a buffer solution, acid and salt is required, but here base is provided. If we look closely at here acid is excess amount, and by the neutralization reaction all the base consumed, and eventually as limiting reactant acid is there, no base is present, and all the base converted to salt. Ultimately, after reaction, acid and salt is remaining. So we can clearly say it form a buffer solution. Now we need to find new concentration of the acid, because after mixing these two solutions, ultimately volume changes. So concentration will also changes, and that we need to find the concentration of acid in mixture. That is, limiting react volume of acid is 10 ml, molarity that is 2.25,
and after mixing the final volume is 40. So at the mixture the concentration of the acid will be 0.0625 molar. Similarly, the concentration of salt at the mixture, that is 0.094. Now from the final equation, that is Henderson equation, if we put all these values at here, now we get pH equals to 4.922. One thing we have to remember, if the concentration Ka of acid is not provided, we need to remember or recall from our memory. That is, Ka of ethanoic acid is 1.8 into 10 inverse 5, and by the simple calculation we get pH is 4.94. This is how we can practice some more of the mathematical problems from the textbook, and we can continue our learning process. Hopefully next class we will discuss about the relative strength of acid. What are the factors that strength of acid can be represented or can be compared? So till then, stay tuned, stay safe, and thank you.